About, so in the classroom we get a lot of theory and stuff like that, but coming into motorsports has helped me kind of apply that kind of a thing. Especially, I mean, this is the one place on campus where you can learn how to weld, you can learn how to carbon fiber melt things together. I mean, you just get a really practical side of engineering when you come to motorsports on Saturdays.
So right now we're taking the air induction system, which is a fully composite carbon fiber model, and we're actually installing the fuel injector bungs, which are aluminum bungs, onto the carbon fiber runners. What we're doing is they have already been applied with epoxy, and so we're reinforcing the structure with carbon fiber. And this is a lighter model compared to last year's air induction system because it's fully composite, and we've actually strengthened a lot of the plenum. The weak regions in the plenum. So this is like the last step. This is probably the fourth time we've built the intake. So we're looking forward to having this work really well. And so far, so good.
Especially outside during like interviews and job applications and stuff like that. Whenever I talk about being in motorsports or hint at what kind of stuff I do outside of my classroom pertaining to motorsports, recruiters are all over me. They love it. So that's great.
Okay, so we started this year, as we did most years, with the plywood base, and then from that we used plywood cross sections, which are based on coordinates given to us by ASCE, which they provide every year. They're just an easy set of coordinates to use that are within the regulations for size. And then we decided to change up how we made the form, and so we used the panels of thin wood called Luan on the sides and plastered over that to get a nice smooth exterior. And then we mixed concrete and placed it over that, and we used a specialized drill this year to do that. And then we altered our placement method from previous years, where in previous years we had just done it entirely by hand. This time we made plates of concrete and we placed them on individually to form the whole thing. And there are 3 layers with 2 layers of reinforcement. And the reinforcement is a geogrid mesh made of plastic which has some good tensile strength. And we made the end caps with foam because we couldn't do that with plywood, obviously. And now we just sanded and painted to get a nice even coating, and then we're going to continue to paint and put a design on it. It's named the White Raven, after a basketball player.
This is the Duke Eco Marathon team. We're looking to make an ultra high efficient vehicle. Last year we were able to compete, but we didn't actually have a full body. This year our goal is to fully encapsulate the driver and really come up with a futuristic design. Right now, our team leader Jeremy is spraying down a coat of PVA. We are molding, or we're preparing the mold so we can make the carbon fiber body. It's the first time we've ever done it, so should be an interesting experience. This is the last coat of PVA. After this, we'll start putting down epoxies, resins, and carbon fiber to get the actual body that we want. Last year we saw about 104 miles per kilowatt hour, so about 170 kilometers per kilowatt hour.
And what does that translate into in terms of miles per gallon?
It's a little hard to quantify that because it's an MPGE number, but it's basically going to Greensboro and back on a gallon of gas. Like with all projects, money tends to be an issue. EAC has definitely helped us out with regards to that, giving us a lot of funding so that we actually have this opportunity. More than that though, they've hooked us up with a number of alumni. Some of the people on the council have lent their expertise, especially Mike, who has helped us with the wheels, brakes, and kind of getting the car rolling.
So we're just basically a club here dedicated to robotics. We have our members work on projects that interest them, projects that we decided to run this year. Our main project was the 2 quadcopters. We're working on a balancing robot right here for Professor. A few of our members are working on BattleBots, which they'll be taking a competition in a couple weeks. And we just look to kind of try and stimulate and help people follow through on their ideas by giving them advice and help along the way, as well as funding.
For me, it's been the one real engineering experience that I've had at Duke. I think a lot of the classes are not project-based, So having the chance to work on a full project from end to end, especially one that is, you know, significant, has been fun. It's been a great learning experience. You know, me and Jeremy have definitely bonded over this car. Long hours, but it's exciting and it's a taste of engineering, what you're going to do in the real world.